Okay, task six. There's two components to task six. Create a table that calculates total gross wages per annum for your factory employees, and the second one is to create a factory floor design. We're using the information from this table to do the first part, so you'll note that we have our four categories: press, trims, sew, and on yours it'll be rack and pack, so just ignore that, and cutters. So our press operators are going to earn $605 per week. So let's just type that one in there. Trims is 685, sew 610, and 655. Payroll tax and work cover insurance mandated by the state government is coming from these two values there, so I've just typed them in there, and we calculate the tax payable by the gross wage times payroll tax, and then work cover insurance is the same, cutters by work cover insurance, and you can obviously drag those across. Therefore your total outlay per week is a sum of those three, and output per week per worker is the productivity of your staff. So I have a cutter that can cut, or I expect my cutters to cut 40,200 pieces a week. A sewer 5360, trims 6,700, and 42,000 press. Maximum rate of production equals max production, and this is the busiest week in the year, and I can drag that across, it's going to be the same. And you're probably asking where you get production from. It comes by naming 3.2 column Z. So make sure you name it without the headings and without the total down the bottom. And it's finding the busiest year. So based on the busiest year of the week, we can determine how many staff we need, which is number of workers, which again is maximum rate of production divided by productivity per worker. I'll actually round this up because we don't want to employ part-timers. Comma 0. So I need 3 cutters, 17 sewers in my factory, 14 trim operators, and 3 presses. Gross wage per week for each category is, if I've got 3 cutters and they earn $700.73 per week, then the total gross is 2,100 for those 3, and for a year it's simply that one multiplied by 52, and drag it across. So my total final wages bill is total wages for cutters, sews, trims and press together, and that 1.3 million is the answer to 6.1. Now to do 6.2, we need to take note of these 4 numbers there. Okay, we need to provide a design of a factory floor incorporating all processes in the production of garments. It should be, sorry. So what we've got, let's start with the material flow of goods in the factory. We've got a truck that arrives with rolls of fabric from our distribution centre, goes to this guy who's the cutter, cuts it according to the patterns. Then the pieces are sent to our sewer here, who we've just calculated the wages for all these staff. Then goes over to trims, where they put on the buttons, zips, pockets, etc. And finally to the press, and out to rack and pack, and finally back to the truck. So we have to be mindful of this flow of goods, or the material flow of goods, if you like, through the distribution center, through the factory. Now, sorry, I'm just finding my sheets. Now we have to go back to our distribution center, task 4.6, and take note of the size of the DC. So you notice mine is 16 by 16, and we're going to copy and paste that into 6.2. So I'm going to highlight 16 rows and 16 columns, and I'm going to put a border around it, and there's my factory. So all of my 3 cutters, 17 sewers, 14 trims and 3 presses all have to fit comfortably into this process, into this space. And if we have a look at some of the rules, so this is an example here of one of them. This is pretty much a sweatshop, so it's not the best one because everyone's crammed in. You try to create a little bit of space if possible. But first one is we have a receivables. The truck, when it arrives, it needs to be an area of 16 square meters, so 4 by 4 cells if you like, or 2 by 8. The cutter, the guy that cuts the fabric, works on a bench that's 4 pink cells. That's the actual table itself, and then the grey area is the bit where they walk around. So they have to walk around on 3 sides. And then we've got our sewer, who takes up 2 cells, 1 cell for the sewing machine, the blue area, and then the grey area where she or he sits. And obviously have to be next to the passage, as does the previous one, the cutter. The trims, exactly the same. So we've got the sewing machine again, and then where they sit there next to each other. And the press area, which is the orange area, is the actual ironing board, like here, and the grey area is where they stand next to it. And again, they have to be next to a passage. From the press, it needs to go to a rack and pack, which should be 8 squares, not 16, sorry. So it can be 4 by 2 or some other place, but it needs to be next to the receivables, so it's close to the truck. Take into account or be mindful of meals area. You try to do something a bit more comfortable than these guys had, because if you provide those sorts of amenities, you tend to get better results from your staff. Look after them, they'll look after you. Also have to put in an office, and the size and location is based on the size of your head. So how important do you think you are, and how big do you want it? Again, on a serious note, the bigger you make it, you got to be. If you have a big office, then it may create resentment with staff who think you're pretty special and important. If it's too small, perhaps it's too humble. So be mindful of the space and how it's perceived by your staff. So where do we start? We start by, remember this is our cutting area. And I'm going to put it in 1, 2, 3, 4, 2, 3, 4. So I'm going to make this my receivables area. And remember, I need 3 cutters. So the fabric comes in here, and I'm going to copy this one. So you have to draw these up yourself. And that's going to be my first cutter. That's the table and the bench around. And because I need 3, I might put one there. Oh, I might put one there. And then the third one there. So it's cutter 1, cutter 2, and cutter 3. Then they need a 2 meter passage, so I've got to allow passage. I'll pick a different color for the passage. Then once the fabric is cut, we need to send it to the sewer, so it makes sense to have the sewer as close as possible to the cutter. Actually, what I'll do, I'm going to put them this way. So if I do that, I'll flip it around so this operator is sitting there facing in this direction. And then I'm going to put a trim operator there. Now double it. So that's 1, 2 sewers, 2 trim operators, and that's one team. And then I might put a space and replicate that all the way through. So team 1, 2, 3, 4. Then remember, this sewer gets out in this direction. Oops. But this trim therefore needs another passageway there. So I'm going to whack another one there. And what have I got? 2, 4, 6, 8 sewers. Remembering I need 17, so I'm going to have to squeeze them in. So I might put another one there. That's 8, 9, 10, etc. I think you've got the idea. So I've turned it from something that was a bit spacious to something which is a bit of a sweatshop now. Not ideal. But from there, the trims, they go to the press operators, which I may put one there and then shift this one up to there. So they stand there, press here. And again, I need 3 of those. So I could put these 3 guys across like that. And once they press, remembering I have to go 2, 4, 6, 8, back to the rack and pack, which is my blue area. So I've got that sort of a flow going. And then I've got room to put a meals area and other such things. So that's one model you can put. The idea is to make it as spacious as you can, which will enhance productivity. Make sure there's minimal transport and wastage occurring by having everything close to each other. Bit of a balancing act, but I'll just quickly show you another one from a previous student so you can get an idea of what the perfect one looks like. You probably won't have enough space for this. But what Rebecca's done is she's got receivables, 2 cutting teams on either side, and then teams of trims and sewers going to the presses, rack and pack, and then straight back out to receivables with a meals and office area here. What's nice with this one is that after a while gels as one team. This is the second team, and to some degree they can compete with each other or benchmark against each other. So if this one's quite fast and this one's slow, then they can obviously see they're slow and improve their performance or whatever. Or as managers, we might start to chop and change some of these workers around to make sure we get a team that sort of can work harmoniously together. So the idea of the exercise is think about the spatial orientation of your workplace. Which direction it faces, how much space there is, how functional it is. Some students put in creche, toilets, all sorts of things. I'll leave that up to your imagination.